All right, here we go. Okay, so I'm recording this right now, and this is a midterm exam review. So I've already put a little bit of something in here just to kind of start with. And you might recall this, might look a little familiar to you. We did a demo at some point last semester, I think it was with joins or something like that, where I had the two minuscule little tables for my faves and so faves. And so I've made it a little bit smaller still. Only, 3 favorite foods for each person, and I've got my little table set up here. So that's just some of the data that I'll start with for the normalization part. So there are going to be 3 parts of this. So the first part is going to be normal forms, data normalization, and just the first 3 normal forms. The next one is going to be an EER diagram. And then the one after that is going to be what? SQL. And let me just see, did I share the whole screen here, or am I sharing? Yeah, I think I'm sharing the whole screen. You guys will have to let me know. If I go somewhere and you can't see what the heck I'm doing, then let me know and I'll stop the share and start it up again. But I think I am. Okay, so let's take a look at the normal forms. And there will be 2 different questions at least in the normal forms section of this. I will ask you to take some data and make it conform to normal form 1, NF1, or 1NF rather, and then I'll ask you to make it conform to normal form 3, 3NF. And I'm skipping 2 because that's what often happens. Often when you take something and fix it for normal form 1, it'll also be fixed for normal form 2. And in order for it to be fixed automatically for normal form 2, it has to already have a primary key here with unique values. And right now we do. I'm giving you that. I will almost certainly give it to you on Wednesday as well. Whatever data, it'll be something that looks kind of like this, and it will already have an ID column so that you don't have to worry about normal form 2. You just have to worry about normal form 1 and normal form 3. So what is normal form 1? Well, I'm giving you the definitions that are in the textbook, more or less, because you will find a lot of different definitions out there. And that's not to say that they're mostly wrong either, or even a lot of them are wrong. It's just there's so many different ways to think about this, and some of them go into much more technical detail in the descriptions of these than others. But I'll give you basically what the textbook says, and these are on whatever I said before in how to review for the midterm exam. I think it's page 323 or 2. Yeah, I can't remember. Whatever it is, look on there. But the first normal form basically says that all values have to be scalar. And what that means is that you cannot have a collection as a value. You can't have a collection of values in a single field. And look at this. Here's what we've got. Here's 3 different values. Whenever you see commas in there, that should make you stop and think, oh, wait a minute. Maybe this is actually a collection instead of a single scalar value. There was another example, I can't remember whose, but someone's data said like number 1 of 47 or something like that. And then the next one said number 2 of 47. Okay, that's another, I hadn't thought of that, but that's another possibility where this is actually something 1 and 47. That's a list of things, even though it's the like an of operator, as it were, separating them instead of a comma. That's still 2 different values. They don't belong in the same field. And so if someone sees something like that in one of their tables, the CSV files, that's something that needs to be fixed. Those need to be broken apart. And you can do that if you just go to open it up in Excel, or if you don't have money for Excel. I don't want to give them money for Excel either. I use LibreOffice, which is perfectly free. There's also OpenOffice, which is pretty much the same thing, totally free. Open it up in Calc, in LibreOffice or whatever, and do a search and replace, and just get rid of that extra value, break them apart, whatever you need to do. So stuff like that. That means it's breaking normal form 1. Here's another one. 3 different values separated by commas. That's no good. Now, the first temptation, I think, to get this into conformity with 1NF is to say, oh, well, I'll break these up across multiple columns now. So instead of foods, I'll have like food 1, food 2, and food 3, right? Now, if this were all the data, you might have a case for that, even though it wouldn't be solving normal form 1. But what if you wanted to add another entry here? Like, what if someone else comes in the family and say, hey, I've got favorite foods too. Why don't you get me into that database table? And maybe they've got 4 favorite foods instead of 3. Well, what do you do then? That means you'd have to add another column just for them, right? And then you'd have to like autofill in null values for the other ones. It's a mess. You can't do it. So putting this stuff into extra columns is not a solution for first normal form. In fact, sometimes it's listed as a second requirement of 1NF. It's like no collections and also no duplicate columns. So if you see like no duplicated columns, that's what they're talking about. They're talking about someone who tried to solve this by splitting this into different columns, which basically are the same thing, but they're just duplicates of each other. Okay, so how do you solve it? Well, if we can't expand this out in this dimension, we only have one other dimension to work with, right? Which is the up and down dimension, which is creating more fields. And so let's go, I'm going to go ahead and grab this and copy it, whole thing here. And let's go ahead and just make a little subsection here. So 3 hashes, as you might guess. This is a third level heading. H3, this is an H2, that's an H1. And I'm going to say this is solving for first normal form here. Paste, there we go. Okay, so what I need to do is split enchiladas, pizza, and ice cream onto 3 rows instead of 3 different columns. So I'm going to take this guy and I'm going to paste it twice. And then I need to change these ID values, right? Because these need to be auto-incrementing and they all need to be unique values. And then I'll just get rid of these one at a time. So the first one just has enchiladas. The next one has pizza. And the third one has, of course, everybody's favorite ice cream. And then I'll do the same thing down here. I'm going to grab the so faves, copy it, paste it a couple times. Pizza. And then next one is just going to be ice cream. And then finally, cake. Oh, and I need to change these guys too, right? So we have 1, 2, 3, and next up 4, 5, and 6. Okay. So this now solves 1NF. This is now conformant with the first normal form because we no longer have collections as values anywhere, and we didn't duplicate any columns. We didn't make like foods 1, 2, 3, and 4, etc. In fact, it's the same table structure as we had up here. We just we exploded it, basically, and composed it. So that is now in conformity with first normal form. So if you remember how to do that, take something like this and just split it up across the different rows like that instead of columns, then you can pass the first part of this, right? It's going to be something just like this. Well, not the same data, but otherwise pretty much just like this. Okay, cool. So what about 2NF?
Hey, Mr. Luke.
Yeah, go ahead.
On so favorite, can the 4 be a 1 or does it have to be a 4 on ID?
This one here,
Yeah.
now that needs to be 4 because 1 is already taken. Each of these values in the ID column needs to be unique.
Okay, so even though it doesn't share the same kind of fave name, the
Yeah, so what you're doing is you're looking at this and you're seeing that there's something wrong, right? And that makes perfect sense. There is something wrong with this. So we can't stop here. This solves the first normal form, but it doesn't go any further than that. We need to solve 2 more. So the problem here is that my faves is repeated 3 times, and so faves is repeated 3 times. So if you recall what these means, like my faves is like my favorite foods, and then SO is the significant other favorite foods. So these are 3 of my favorites, and then there's 3 of her favorites. So what's happening here is that we're getting repeating values down here, right? We've got 3 my faves now and 3 so faves. We didn't before. It's like we fixed this problem, and in the process, we made another problem. So this is where we have to start thinking about going through, the next 2 normal forms. Now, the next normal form, second normal form, we actually don't need to do anything with this one. because the second normal form basically said, again, using the textbook definitions, every non-key column has to rely on a primary key column that has unique values in it. And this already does, right? We started out with an ID column, so we just expanded it here. We still have unique values in ID, and these entries are dependent on it. So we're already in second normal form. This happens a lot. When you solve first normal form, chances are it's already going to be conformant with second normal form. The only way it wouldn't be is if we didn't start out with this ID column, and then to conform it to second normal form, basically we would have to add that primary key column there if it wasn't already there. But I won't make you guys do that in the exam. Okay, so the third normal form, and I think this is what's bothering you, Nish. Let's see if this is what it is. The third normal form it sounds very similar to the second one. The second one says, okay, so every non-key column has to depend on a primary key with unique values. The third one says every non-key column must depend only on the primary key and nothing else. So let's unpack that a little bit. So as I was saying before, it is possible to have a compound primary key. And sometimes you even need one, like that invoice line items example from the textbook, right? But in that case, you have two columns that are together considered to be the primary key. It's a compound primary key. So in that case, you're not breaking third normal form at all. In this case, however, things are not really going that smoothly for us. We've got an ID, sure, fine. We've also got this guy over here, and the items over here seem to rely on both of these things, right? Enchiladas, pizza, and ice cream, yeah, those are all my faves, right? So they all depend on my faves. But they also depend on this guy over here, which we've said is our primary key. This one clearly is not the primary key, right? Or it shouldn't be. And so we have data here that's relying on something other than the primary key. And so that is, I think, what's bothering you visually about this, and that is what we need to change in order to make this conform to third normal form. So let me go ahead and once again, I'm going to copy this whole thing here, paste it, and get it down into the third normal form here. And we're going to have to bust this up. Now, just to let you know, normally when you break this up, which is called splitting or decomposing sometimes, normally when you do this, you're setting up a condition for a foreign key and a one-to-many relationship. Usually. You're separating something out and then something else is going to depend on it. In this case, it doesn't happen to do this, which made me hesitate to use this as an example, but I think that it still shows the solution, so I think it works. So basically, I need to split these two guys into two. I need to have a my faves, and then I need to have a so faves. So I'll actually go ahead and paste this twice instead of just, well, I already copied it here. I'll just paste it again. So this is going to be, I'll call this my fave foods, and then this is going to be so fave foods. And from this one, I will delete the last three. And this one, I'll delete the first three. And then I need to fix some stuff here. So first of all, let's go ahead and get these. Let's fix this for you, Nish, because you're right that was felt weird, and now it feels better again. 1, 2, 3, and 1, 2, 3. But the only reason I can do that is because they're in different tables now. I couldn't do that when they're on the same table. And we've got a redundant column here now. This my faves column, which was the thing that was bothering me up here, it's no longer necessary because my faves is the name of the title. It's the name of the whole table here, or something similar to that. So I don't need this. I'm going to get rid of that whole column altogether. There's that, and then get rid of this guy, and then get rid of my faves wherever you see it until we're down to 2 columns again. And we'll do the same thing right down here. Get rid of that faves column. And then this, oops, what just happened? Let's try that again. Like so, okay? So we've got 2 different tables now. We've decomposed this into 2 tables, my fave foods and so fave foods, busted it apart, and now we've got a much simpler situation. We only have 2 columns. We have 1 non-key column that very clearly depends on the 1 primary key column. Same thing down here. We have 1 non-key column So very clearly depending on the primary key column and no other column. Even if we had other columns in here, these would not be dependent on them. So that's the third normal form. So the first normal form, I think, is the easy one. It's easy to spot, at least. And then you just have to remember, okay, expand this downward instead of to the side. And then if you've already got a primary key, then you can jump to the third normal form. And that one's a little bit more tricky, but just think of this as, yeah, this is kind of like a one-to-many relationship, which means that it really should be in two different tables like this. Yeah, so that would be the third normal form, to be actually split it up into two different tables, almost always. Almost always on third normal form to conform to it, you wind up splitting up your data or decomposing it into two or more tables like this. Now, I probably could go longer than this. I probably should in this case because I'm seeing some repeating values over here, right? There's pizza and ice cream here, and there's ice cream and pizza in this table too. So whenever you see repeating data like that, it should give you pause. Maybe there should be another table here called foods that just has, an ID and then just the name of foods. And then these other tables could refer to it with a foreign key. That's probably, I would take this one step further and do that instead of leaving it like this. But we've done our job. This now conforms with 3NF, and so I'll go ahead and leave it here. So any other question about these guys here? First normal form, second or third normal form? Okay, cool. So
Did we skip the second?
the second normal form is already satisfied because there's already a primary key with unique values. So yes, we skipped the second normal form because once we got this into normal form, it was already met the needs of second normal form. And I can tell you right now that will happen on the midterm exam as well. Does that make sense? Okay.
Yes.
Okay, good. Okay, good. Other questions? Okay, so the second portion of the exam is going to be an EER diagram, which I've already told you it will probably be a many-to-many relationship. So let's pop over to MySQL Workbench. Are you guys seeing MySQL Workbench here?
No, we see the studio code.
Still seeing that. Okay, cool. Thank you for letting me know. Let me go ahead and stop share momentarily. Yeah. And I will present again. This time I'm just going to go ahead and do the entire screen. Well, you know what? Doesn't matter. The rest of it's going to be in MySQL Workbench, so I'll just go ahead and share that. There we go. All right, you guys are seeing now, right? Okay, let me know if not, okay? So, yeah, EER diagram, and you're going to do it in MySQL Workbench. And so for that, you're going to head on over to the Home tab, as you guys know. And I won't ask you to make an EER diagram of an existing database. I will ask you to go ahead and build it from scratch. So I'll ask you to create a couple of entities, and I'll tell you what columns to make, and then ask you to do the relationship between them. So let's go ahead here. Go to the Home tab, and then here's the Models section. So know that if you're seeing something like this, then just go ahead and get to the second of these two icons in the pipe navigation on the left. Click on the plus sign to make yourself a new diagram in a new model. Actually, just the new model. Make the new diagram by Add Diagram here. So once you get here, double click on Add Diagram, and it'll get you out to here, and then we're good to go. So let's say I decide to do something like the foods, where I said, okay, I should probably take this a little bit further, right? And really I should have, I don't know, I should have like a table for the family members, however many there happen to be. And then I should have a separate table called foods, and then there should be a one-to-many relationship between, no, you know what? There should be a many-to-many relationship between them. Why? Because each of the family members can have any number of favorite foods, And each favorite food can be a favorite food of any number of family members, right? So whenever you see a one-to-many relationship going in both directions, that means you have many-to-many. So I won't ask you to do any analysis about that. I'll just ask you to go ahead and create it. So this is the icon for placing a new table. And let's go ahead and do the little example that I was just talking about. So I'll put in a new table here, and I'm going to call this one, well, let's go ahead and give it a name here. I'll call this, yeah, I'm just going to call this faves, right? Because this is going to have the family members in there and then which foods are our favorites. So I'll say something like, in addition to the primary key, put in these columns, or maybe even just this column. Maybe it would just be one. So you'll have to know, yeah, when I say in addition to the primary key or in addition to the ID column, you know, yeah, I create a column called ID. See if I can get this working. ID, and it's going to be primary key, not null, and I'm going to put an auto increment on it, like so. And if you recall from our work, all you have to do is type in the column name and then go over here and tap on AI for auto increment, and it'll fill in the other stuff for you. And let's see, each family member needs to have a name. One of the weaknesses about having like my foods and so foods being in their own tables is that then you have to create, if another family member comes along and says, hey, I've got favorite foods too, then you have to make a new table for them, which it's not the end of the world. You guys are going to be doing that for your projects. In fact, every new user that comes along is going to need to create their own table. So yeah, it's not the end of the world, but still, it could be seen as a weakness. A name is just a name. It's a string. So just stick with varchar 45 and say not nullable. And there we go. We've made the first table. And then I might say, okay, so make another table that in addition to the primary key, it's got a column for foods. Okay. So I've got faves, excuse me. Let's go ahead and make another table here. And modify it, name it foods. And then again, no, your primary key means you go down here and you type in ID and you make sure the primary key not nullable and AI, boom, for auto increment. And then for this one we have, let's just call it food. And then varchar 45 and then not nullable. And then I might say, so create a many-to-many relationship between them. Or you know what I'm going to do? I'll tell you. I'm not going to say create a many-to-many relationship. I'm going to give you instructions like they gave you in the textbook, and I'm going to say, okay, so like if it were using this example, I'd say so. You know, each name in faves, each person in faves can have any number of foods, and each food can have any number of people, you know, who favor it. So that if you see something like that, that means many-to-many. And many-to-many is not the easiest thing in the world to code necessarily, but it's very easy to do as part of an EER diagram in MySQL Workbench. You just go ahead and type in the N to M here, or click on it rather, that's your many-to-many, and then click on one, and then click on the other, and what it does is it creates this junction table here. And if you want to make sure it's working, drop down the indices, depending on who you ask. It's indexes on Windows, indices on a Mac. And it should have added these foreign keys in there for each. Don't worry about the fact that foods has faves. I don't really like that naming convention because it really should go both ways. It should be foods has faves has foods to show the many-to-many relationship here, or really just foods faves, which actually I'm going to go ahead and I won't ask you guys to rename it or anything. But yeah, this is, I think, the way most people would do it. Just call it foods faves. There we go. And then once you had something like this, you'd be good to go. There's your many-to-many relationship. And I'm going to go ahead and hit Control S to save this. And I'm going to call this Bispo Midterm, or whatever I ask you to call it. It's going to be the MWB file. And you're going to save that in. Boom. And you're done with that portion of it. Questions about this part? Okay, let's try to recreate something like this in MySQL, but this one let's do slightly different. Instead of doing many to many, let's just do a one to many. So let's see. In fact, yeah, you could actually do this as a one to many between foods and users. Kind of sort of. Anyway, that's the way we'll do it. So I'm going to go ahead and close this here and close this, and we're good to go. I'm back in local instance, and I'm going to create a new SQL tab by hitting Control T for tab. So this is going to be, just like the chapters SQL files that you guys have been submitting. You go ahead and just save it as an SQL file, put your last name at the beginning, and then submit it like that. So the things that I'm going to be asking for you guys to do, it's all, as far as I recall, it's all Chapter 11 stuff, which is creating databases, tables, and indexes. And I'll show you exactly what I'm looking for. So probably, well, no, I will ask you to create a database, because without that, none of the rest of it works. And I might do a little bit of unstated extra credit, like drop database if exists, and then you put in the name of the database. So maybe I'll only ask you to create the database, but then if you remember to do this beforehand, maybe I'll give you a little bit of unstated extra credit for it. As long as no one asks about it out loud, because that nullifies the whole thing for everybody. So I'm just going to call this, let's see, Fave Foods. Drop database if exists, Fave Foods, Control Enter, and then create database, Fave Foods. There we go. And then we've created the database. And if you want to see it, you go ahead and hit the refresh over here on the schemas. And there is, oh, it looks like I already had Fave Foods, but luckily I did this first, and it dropped it and then added the new one. And I can tell it's the new one because there's no tables, it's empty. So we got to create a table. So I will probably ask you to do 2 tables. In fact, I know I'm going to ask you to do 2 tables because we're going to need to do a foreign key relationship between them to do a one-to-many. So yeah, that requires 2 tables. So let's go ahead and do one of them. I'm going to do create table foods. And then remember the code block here. Whenever you create a table, you can't just leave it at that. You got to tell it what columns are going to be in there. You might think, yeah, I could just leave this empty and then add the columns later on, but you can't. You got to put at least one in there, which is the primary key. So this is another case where I might say, yeah, make a table called foods, and in addition to the primary key, give us a food column with variable character data type. There might be some cases where I leave the data type off of there, but only when I think it's obvious or should be obvious. As with the primary key, right? You should just know ID int, it's going to be an integer, almost always. It's got to be not nullable. It's going to be an auto incrementer, and it's going to be a primary key, like that. So like almost anything other than a junction table, you're going to be doing something like this right at the beginning. There's really no need not to. Well, okay, there is a non-zero number of times where you do not do auto increment. I think one of those examples was at some point last week we did, I guess we did a one-to-many table, and the table was for countries. And we said, okay, so instead of just using our normal auto incrementer ID, let's go ahead and put the country codes in here. So in that case, it would look like this instead. It's still an integer. It's still not null. Still the primary key. I think we call it country code instead of ID, but otherwise it's just like this. So in that case, you would not want this auto incrementing. But most of the time, you just want it to start at 1 and then just keep adding integers as it goes. So let's see, I'll go ahead and add food, varchar. I'm going to go ahead and just stick with 45 since that's what my SQL Workbench likes on the EER diagrams. Yeah, why not? And then this would be like one table. So cool. Go ahead and do that. And as you guys know, I always like to do a select as I create stuff or modify it, just to see what I got here, if anything. And there it is. There's my ID and there's food. There's no entries. I don't think I'm going to ask you to do any entries. That's like last semester stuff. Right? You guys learned how to do insert into when we did chapter 5 last time. So This is all DDL stuff, right? Data definition language. This is like creating databases, creating tables, adding keys, or constraints, and maybe altering those tables, adding columns and so on. It's all DD stuff. So yeah, I don't think I'll mix it up with any D or sorry, this is yeah, data definition. Anyway, going forward. So we got our foods, and then we want to go ahead and create the next one. So I'll say, now create the table that's going to depend on this one, right? So there's going to be a one-to-many relationship. This one's going to have a foreign key, but it starts out the same way. It's going to be create table, and then faves, right? So this is where it's going to store the family members and their favorites. Need the code block. Start out the same way. ID int not null, auto increment, primary key, like this. If you don't have this in your fingers yet, type it a bunch of times until you do, because you're going to wind up typing this over and over and over again, unless you put it like as a snippet for yourself or something over here. But even so, just get this one down. Okay, so in this one, I might ask for like a name. So instead of doing like my and SO, maybe I'll ask for like actual family member names this time. So I'll do name, and then you're going to need, like I'm going to ask you to do a column that's going to be a foreign key that references the foods table and references the ID column in the foods table. So let's go ahead and do this one at a time. Name next, and this is just going to be our old friend varchar 45, and it probably should not be nullable. Right, I think family members should all be able to be referred to by their name. And then I'm not sure if I'm going to tell you what this column should be named. I guess I probably will, but hopefully you're familiarized with this by now. It's like if someone tells you, yeah, okay, so you're going to need a column in faves, and it's going to be a foreign key that references the ID column in foods. Like you should already know what that's going to be named. This is going to be called foods ID, right? It's normal naming. Whenever you see this, you know exactly what it's referring to. And, later on, when you guys work with this stuff, if you do, and you come up with some coder who does not do it this way, you're going to get irritated with them because they're not doing it the way everyone else does. So this one is going to be int, not null. And that's it, though. You don't do like auto increment or primary key or any of that stuff because it's not a primary key. It's not auto incrementing. It's referencing this ID over here, which is. So foods ID int not null, and then let's go ahead and put our constraint on there. So one more comma, and then we will add a constraint. And the constraint would give it the constraint name. So I told you about what I think is the best naming convention, or at least one of the best ones. There's different styles out there, but I would say like faves fk foods, right? So it's the referencing table, fk for foreign key, and then foods, the referenced table, referencing the foods table, right? That's what we called it, foods. Yeah. There are people who would put the FK at the beginning. There are people who would add in the names of the columns. Yeah, I don't know. Different coding styles. So this is going to be the kind of constraint that we're putting on there is a foreign key. Tell it which column we're adding it to, foods ID, and references. You got to tell it which table is being referenced. It's foods, and then what column there is being referenced, ID. And I always want to put a semicolon there, but don't. Haha, I remembered. So 3 columns, and then adding the constraint. Now, just for fun, before I execute this, I wanted to show you a couple of shorter ways to do this, right? And I think one of them we've gone over already. It's going to be the same thing, but without the constraint keyword. Let me go ahead and get rid of this guy. There we go. So it's going to be just like this. Let me take this down a little bit, except that you don't have to put in this line 16 here. So I can do this. Let me copy and paste this whole thing. Paste, and I can just get rid of this line. Just gone. And this does, yeah, it seems at first like it does the same thing. So what's the difference? Why put on this constraint clause here? Well, constraints basically, I mean, it gives you more flexibility in a few ways, but basically the important difference is that it allows you to name the constraint. And there are times when it's useful to know that. Now, can you find out what the name of the constraint is if you ever need it? Yeah, you can. But it's nice to know it from the beginning, and it's nice if you can name it because then you know you're naming it with your own naming convention and not just what MySQL server decided to put on there for you. So there's that. But if you do it this way on the test, that's fine. No problem. If this is easier for you guys to remember for the test, that accomplishes the same thing almost. Good enough. Now, let me show you one more way to do it that's even shorter than this, because I don't think anyone's asked me this semester, but usually someone asks. So, okay, for the primary key, we were just able to say primary key in the same, right, stop it. We were able to say primary key in the same column without having to put it separate down here at all. Why do we have to put foreign key separate from the actual column definition? Well, you don't. Let me show you what it looks like down here. Now, let me show you first off what you'll be tempted to do, and then I'll show you what works. So you might be tempted to say, okay, well, I'm just going to throw that onto the same line of code here, and I'm just going to do it like this. And yay, that should work, right? After all, it's the same, kind of syntax as putting primary key. We start with foreign key and then give it the stuff that it needs. Well, this is not going to work. If I do Control Enter right now, I'm going to get an error message, right? And the reason is, for whatever reason, when you're doing a primary key, you need the primary clause and the key clause. But in this case, you don't need foreign key. And you certainly don't need foods ID, right? Because we're already telling it which column it is. So let's get rid of this one first, and let's see if it works. I'm not expecting it to work with this either. So foreign key references foods ID. So this is what I would expect to work personally. Control Enter, nope, another error message. So as it turns out, with the foreign key, you just do this. So this is, as you can see, a much shorter way of doing it than this guy up here. This is the way I like to do it. A lot of people do it like this instead. I think if you look on W3 Schools, it'll show you this. And then some people will show you this version as being the least verbose, right? So let's go ahead and try this super simple version. I'm going to do the Control Enter, and boom, there we go. Good to go. I'm going to do a select all from faves. There it is. We got the ID, we got the name, we got the foods ID. As you guys might recall, you can't really check. Yeah, these aren't even showing up over here. This has been acting wonky this whole time. Like, I want the tables to show up over here. And fave foods, right? So why is this not? Oh, do you know, did I not run these up here? Let's see. No, I did. Great. Yeah, I ran them all. I don't know why. This has been happening to me recently, where the navigator won't refresh over here no matter what I do. There should be multiple tables in here that I can get to, and I can't get to them. So even if that's not happening, you might recall that if you go to like the table inspector over here and you try to go into foreign keys and refreshing it, like it's not going to work. It's going to throw an error message at you, and it's just a bug in the program. If you really do want to see this stuff in action, then you can go to the models, and instead of doing the plus, you can go here and go to create ER model from database. I'm not going to do it because I don't want you guys to think that's going to be part of the test. It's not. Once you get to this point in the SQL code, then you're done with that part of it. We still have to do the alter table commands. But I'm just saying that if you wanted to check and make sure that that foreign key is actually working, then a good way to do it is to go ahead and run, create an ER diagram from an existing database and then have it show up there for you. Okay, so let's do a couple of alter commands. So I said the alter table commands, the ones that I want you to know are how to add a column and how to rename a column. I think those are two of the more commonly used ones. So alter, it's pretty simple syntax. We do alter table, and let's say we alter foods, and let's go ahead and do let's do the rename column. Rename column, and let's see, what did I call these things up here? Let's see, where is it? Food. So I've got ID and food. So I don't know what. It doesn't matter. Just know how to do it. So rename column food to food name. I guess I don't know. So Control Enter. It's happy. If we do the select all from faves, there it is. It's called from foods. There we go. Now it's food name instead of just food. Let's add a column. So alter table foods, and then add column, and I don't know, nutrition information, which maybe, I mean, obviously this would be non-scalar data, right? There's a whole bunch of stuff in there. If you try to put it in one field, it would be a whole bunch of lists of stuff, which would be no good. But maybe it's just a link to an online API that spits out nutrition information for whatever it's queried. I don't know. And you've got to treat this like, you were doing a create table, and for the different columns, you have to tell it like what the data type is and whatever other attributes you might want. So nutrition information, if it's going to be a link, then it's going to be our old friend varchar, right? We'll do the varchar 45, and then maybe we don't want this one not null. Maybe we want it nullable, so we'll just leave it like that. So I'll do Control Enter. It adds the column. Let's do select all foods, and there it is. I now have ID, food name, and nutrition information in there. And at that point, that will be it. I just want to show you guys that you can do these two as one single statement. I already ran them, so I won't execute this, but just to show you that there's another way to code this. You can do alter table foods, and then do the two separated by a single comma, like a list of commands. So if we did rename column, and what was it before? It was name to food name, I think we did. Yeah, there it is down there. And then just do a comma, and then add column, nutrition information, and it is varchar. So normally I'm looking for a very specific number of SQL commands. That's the first thing I look for to see, okay, were all the questions answered? Was an attempt made at all of them? But in this case, yeah, it could be either the two separate commands for two different alter tables, or you could do it all as one, like this. And so I think that brings us to the end of the review. And yeah, I think it does. I don't think there's anything I left out. Any questions about any of the SQL stuff now? Or anything else?
So all we just did should be on the midterm for the SQL?
Yeah. So there are creating a database, creating a table, adding a foreign key to a table, which you can do any of these three ways is fine with me. You can even do this super shorthand one if you want to, where references is just thrown out of the same line there. And then doing an alter table, renaming a column, and an alter table add column. So yeah, create database, create table, add a foreign key, alter table add column, and alter table rename column to something else. Good. Other questions?
Could I see the last one?
Yeah. Oh, this guy, right. Here's a case where name might not be the best thing to name something anyway, because it looks like it's trying to reserve that word. So again, if you see that, it doesn't hurt to do this, or what's more common is to use the backticks for identifiers. Either way. I don't think that's strictly necessary, so I'll do it. Okay, any other questions before I stop the recording? Okay, very good. Let me go ahead and get this stopped.